Why do we dream? Tonight, you're going to live through 4 to 6 completely different stories. You'll fly. You'll fail an exam you actually took 10 years ago. You'll talk to someone who isn't around anymore. And tomorrow, chances are you won't remember a single scene. We've been dreaming since we existed as a species. And yet, there's still no definitive scientific consensus on why we do it. Today, we're going to walk through the theories that best explain this, what neuroscience says, what's happening in your brain while you sleep, and why dreaming might be far more useful than it looks. Before the theories, a quick foundation. Sleep isn't one uniform state. We cycle through roughly 90-minute periods, alternating between slow-wave sleep and REM sleep, rapid eye movement. Most of the vivid dreams we remember as stories happen during REM. During REM, the brain is almost as active as when you're awake, but the body is paralyzed in a state called muscle atonia. It's literally a brain switched on inside a body switched off. That's already an important clue. If the brain spends that much energy dreaming, evolutionarily, it has to be doing something. The first major scientific theory, or pseudoscientific, depending on who you ask, came from Sigmund Freud in 1899. To him, dreams were the disguised fulfillment of repressed desires. The weird content of a dream was a facade hiding a deeper meaning. The problem: this idea is virtually impossible to prove or disprove using the scientific method. There's no way to measure a repressed desire in a lab. That's why, through the 20th century, neuroscience moved away from psychoanalysis and started looking for explanations based on what the brain is physically doing while we dream. In 1977, researchers J. Allen Hobson and Robert McCarley proposed something radically different: the activation synthesis hypothesis, published in the American Journal of Psychiatry. According to this idea, during REM sleep, the brainstem fires random electrical signals up to the cerebral cortex. The cortex, the part in charge of making sense of information, receives that noise and tries to build a coherent narrative out of it, using whatever memories, emotions, and associations are available. In other words, a dream wouldn't carry a hidden message. It would be the brain trying to make sense of internal electrical chaos. That's why dreams mix your boss with your childhood home and a math exam. There's no script, just improvisation with whatever material the brain has on hand. This theory explained very well why dreams are so strange, but it left one question unresolved. If it's pure randomness, why do dreams tend to have such consistent themes across people? Falling, being chased, exams, instead of just shapeless noise? This is, today, one of the theories with the strongest experimental backing. During sleep, particularly certain stages, the brain reactivates neural activity patterns similar to the ones it had during the day. It's as if it's replaying what it lived through. In a landmark 1994 study published in Science, researchers Matthew Wilson and Bruce McNaughton recorded large ensembles of hippocampal place cells in rats during a spatial task and during sleep before and after it. Cells that had fired together while the rat occupied a specific location showed an increased tendency to fire together again during the following sleep, a direct sign of the brain replaying the day's experience. This suggests that sleep, and possibly dreams themselves, are part of a memory consolidation process, the brain deciding which information moves from short-term to long-term memory, and which synaptic connections get strengthened or discarded. Psychologist Rosalind Cartwright took this further into the emotional realm. In a 1991 study published in the journal Dreaming, she followed 49 people going through a divorce. Those who incorporated their ex-spouse into emotionally intense dreams showed significantly lower depression and better life adjustment a year later than those whose dreams lacked that emotional engagement. It's probably not a coincidence that after a stressful event, we often end up dreaming about exactly that. There's an evolutionary theory proposed in 2000 by Finnish researcher Antti Revonsuo, published in Behavioral and Brain Sciences, the threat simulation theory. The idea is simple. Dreaming about dangerous situations, being chased, falling, attacked, would work like a flight simulator for the brain, mentally rehearsing escape or defense reactions in an environment with no real risk could have given our ancestors an evolutionary edge. It lines up with an interesting data point. Dreams with negative or threatening content are notably more common than purely positive ones across very different cultures and eras. A 2006 study of 212 recurring dreams found that 66% contained one or more threats. Some support for the theory. But it's worth being honest here. This theory is contested. Other researchers, like Susan Malcolm Smith and Mark Solms, tested the same predictions and didn't find that threats are actually overrepresented in dreams the way Revonsuo's model predicts, calling into question whether rehearsing danger is really the main job dreams are doing, or just one ingredient among several. Science around this is still an open debate, not a settled fact. The uncomfortable truth is this: no single theory explains everything on its own. The current scientific consensus leans toward dreaming not having one single function, but several overlapping ones: processing and consolidating memory, regulating emotions, possibly simulating threats or challenges, even if that piece is debated, and quite possibly partly a byproduct of the brain being highly active with no awake body to distract it. It's not as satisfying an answer as dreams predict the future or dreams fulfill wishes, but it's the one best supported by the evidence we have so far. So next time you wake up from a strange dream, you'll know it's probably not a coded message from the universe. It's your brain reorganizing memories, rehearsing danger, and trying to make sense of its own electrical activity, all at the same time. If you enjoyed this, drop the strangest dream you remember in the comments. It might be the next topic on the channel. See you in the next video.